review. I still don't get it, one-step equations. So if you're still having trouble with one-step equations and you're just not really understanding the concept, it's more than likely not the process you're not understanding, but it's really like the understanding of why are we doing this and what exactly everything's about. So the main important thing we just need to make sure you understand, okay, is first thing this equal sign, right? Remember, the equal sign is when we use it in a statement saying that I have something on the left is equal to the right in quantity, in value, right? Think of like things you can weigh. The weight is exactly the same. They're equal in weight or equal in value. Well, a lot of times we're just going to be dealing with numbers. So that means the quantity, think of money if you want to, the value of that money is exactly the same. So it goes back to a lot of the translating that you can think about in your head. If I say 2 times a number, right, equals 6. So that means 2 times a number, I'm going to take 2 multiplied a number equals 6. Well, in that statement, I'm not telling you what that number is, right? It's an unknown. So remember, when we have an unknown, we use a variable. So I could say 2 times, let's say that number is p. So 2 times p equals 6. So remember, we have that unknown, or we have that value. So what happens is you could say, oh, well, 2 times a number equals 6. I know the answer is 3. That's the answer that makes it true, right? Well, when solving one-step equations, what that process you're doing in your head, we actually just write on a sheet of paper because remember, on some of these problems I came up with irrational numbers, fractions, some of these numbers that it might be very difficult for you to do in your head. So to solve this systematically, if I say 2 times a number, and what I want to do is I want to get rid of this number. I want to find this value by itself, and I'll explain something in a second. So to undo multiplication, I'll divide. Now again, why am I dividing? Or why do you use the inverse operations? Remember, an equation, if I say 3 equals 3, right, you know that statement's true. And if I say p equals 3, that means p equals 3. The unknown equals 3. The unknown is not unknown anymore. The value of p is 3, right? This is equal to each other. You could say 3 is equal to 3, and you could say p is equal to 3, right? So you could say 3, p, 3. They're equal to each other. So that's what I want to do. Right now, I have this p, and it's being multiplied by 2. I need to get it so it looks like this, so then it equals whatever's on that other side. So I divide by 2. Now, the reason why I divide on both sides is you need to look up the division property, or actually all of them, division, multiplication, addition, subtraction properties of equality. Whenever we're doing an operation on an equation, we have to make sure we do it on left and the right side. Otherwise, our equation's not going to hold up. It's not going to be the same statement that we use, and we're not going to produce what we call equivalent equations, which is another video you can take a look at. So 2p divided by 2. 2p divided by 2 gives us 1. 1 times p equals 6 divided by 2 equals 3. So it's really important. The reason why we use inverse operations. See, inverse operations of multiplication and division are going to give you a 1. All right? These produce a 1, and that's so important because 1 times p is p equals 3. So I can see that value equals 3. So that's why it's so important to use your inverse operations to get to 1, and then because 1 times p is p. Now the inverse operations for addition and subtraction get us to be 0. And I'll just give you an example here. Let's say I did, and let's maintain that p equals 3 again. So let's just do p, let's do p plus 3 equals 6. So now I'm going to be adding. So now I say some value plus 3 equals 6. Well, the same respect. Over here, I divided. It was being multiplied, so I divided. Here, I'm adding a 3 to my variable, so I'm going to have to subtract. And I subtract on both sides of the equal sign. Okay? Now, you can't subtract 3 from p because you can't do that anyway. You don't know the value of p. We got to find the value of p first. So you can only subtract your numbers from numbers. So therefore, positive 3 minus 3 is 3 plus 0, which equals 3. All right, so addition and subtraction take us to 0. Multiplication and division take us to 1. And that's so important. That's like the crucial idea, because now you have p plus 0, you know, is now p, which equals 3. So what we call when my variable is isolated, we now know the value of that makes the equation true. And otherwise, just not assume that you know the value is true. Take the value and plug it back into your equation, just like when we did evaluating. So you could say 2 times the value of p, which is now 3, equals 6. Well, of course you know that's true, right? 2 times 3 equals 6. Let's try it over here. 3, still good, 3 plus 3 equals 6. And again, that makes it true as well. So hopefully by me going through this little stuff, that really helps you out with how we solve one-step equations. Thanks.